and these guys. Secant to the mx times tangent to the nx dx, and some others. Okay. Okay, so as far as the sine and cosine stuff goes, that's generally not all that much of an issue. So, looking for something here. It's like cold in my house. And warmer outside. My insulation in this house is really good. Even in the summer, it's really hot outside. It's kind of cool in the house. Okay. So we'll start with sines and cosine. Now, the easy type stuff would be if I had something like this, right? Because if you remember, sine squared x is actually the sine of x squared. And so the obvious thing is to let u equal sine x. And so then the du would be the cosine of x dx, and you just shove it in. And so we're integrating u squared du, which is going to be u cubed over 3 plus a constant c. By the way, Art Moore, he does it like this. And so then, because these two things are the same, he then integrates. Now, see what he's trying to do? I just think that he's doing it too early. This is the kind of thing that physicists do. I can remember all my physics professors doing this shit. Oops. Okay. And for that matter, if I had something along these lines, where, you know, we've got, let's say, sine cubed x cosine to the 4th x dx, as long as one of them is odd, we can break off one of the sine x's and then be left with this, right? And then do this, change sine squared to 1 minus cosine squared x. Okay. And so then if I was to let u be the cosine of x, du is going to be negative sine of x dx. So I'll plug all of this in. Negative 1 minus u squared, u to the fourth du, which is the integral of u to the sixth minus u to the fourth du. And so it's u7 over 7 cosine 7x over 7 minus plus the constant. That noise. Okay, and if they're both odd, then you could have a couple correct answers. So let me just illustrate from this easy one here. Number one, if we were to let u equal sine x, then du would be cosine x dx. And so our integral would be sine squared x over 2 plus a constant. Number two, if I was to let u be cosine x, then du would be negative sine x dx. Okay, and so our integral would equal negative cosine squared x over 2 plus a constant c. They both have to be correct, right? So maybe most of you would have written the answer like that, and a couple of you would have, for some strange reason, done this. But anyways, if you reorganize everything, what you get is sine squared x plus cosine squared x equals some constant, C0, which we know to be 1, okay? So this happens from time to time. All right. Where'd you go?
I'm on break, but I'm not really because we're having another meeting.
Took him on a walk.
Huh?
Took him on a walk.
Yeah.
Trevor was looking for him. So now, when are these things more challenging? Well, we've already kind of seen this last semester because I made sure we looked at this thing. So what you have to use is one of these trig identities, minus 1/2 the cosine of 2x. And for that matter, we might as well cosine squared x dx. The identity that we use there is 1/2 plus 1/2 the cosine of 2x. And so when you finish this guy off here, we get this. And this guy we get okay. And when both of the powers are even, like if we're doing sine squared x cosine squared x dx like that, then we have to do this mumbo jumbo. 1/2 minus 1/2 the cosine of 2x times 1/2 plus 1/2 the cosine of 2x dx. Yes, we actually have to do this. Now, this isn't hard, but it sure is a pain in the ass. So it's 1/4, and then it's going to be minus 1/4 cosine squared of 2x, which then we have to break apart again into 1/2 plus 1/2 the cosine now of 4x to arrive at our final destination here, which is going to be 1/4 minus 1/8 and then minus 1/8 times the cosine of 4x dx equals blah, 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 blah. All right. So the story there is that we got a bunch of manipulation to do. Okay. Now I would never ask you something like sine to the 4th times cosine to the 4th, but it doesn't mean you shouldn't search those, problems out. Okay, now let's shift our attention to
How did it go to a cosine of 4x?
because cosine squared of any theta is 1/2 plus 1/2 the cosine of 2 theta. It's an identity. So,
Okay, I see.
Yeah.
Because it was okay, I got it. Thank you.
okay. So now let's turn our attention to the secant tan stuff. And again, there are some who are, easier than others. Like, for example, if they're both odd and have just one, right? That's easy, right? That's just secant plus the constant c. And what else might be kind of an easy one? Secant squared, right? What about tan squared? Anybody want to take a stab at this one? It's ridiculously easy. You just use an identity. Tan squared plus 1 is secant squared. So this is secant squared x minus 1 dx. And so that's tan x minus x plus a constant c. Okay. So I think that if they're both even, it should work out nicely. Okay, so here's one for you guys to try for 60 seconds. So you give that a shot for a minute or so. All right, what did you come up with? Since the derivative of tan is secant squared, what I'm going to do, I'm going to break off one of those secant squared x's. And then I'm going to convert the middle one so tan squared plus 1 is secant squared x okay. And now we'll let u equal tangent of x. So du is going to be secant squared x dx. U to the fourth, u squared plus 1 du, blah, blah, blah. Okay. All right, so the easy cases. Now, if you were in my math 180, I went through this next one, we've already done it. Not for you new people, maybe we didn't. Harder case. So in the hard case, when I have secant mx tan nx dx, it's when m is odd and is even. Now, the reason we're doing all these is because they naturally show up after we do a very specific type of variable substitution, a trig substitution in particular is what we want to be doing. And here's the first one. Just integrating secant of x. Okay. So there's a trick to this one. You multiply by secant x plus tan x divided by secant x plus tan x dx. Okay. So then we multiply it out. We've got secant squared x plus secant x tan x in the top, and then I'm going to switch the order of the bottom just so you see clear as day what's going on here. So if you were to let u be the bottom, then du is just going to be that entire top times dx. The derivative of tan is secant squared, right? The derivative of secant is secant tan. And so this is just the integral of du over u. Come on, pen. There we go. And so that's what we get. Okay, now as a homework one, make sure you do this one. Make sure you do the cosecant x. You do the same exact trick. However, when you check the answer and the table of integrals, it's probably not going to be the one that you have as your answer. So you're going to have to use an identity or do some kind of manipulation. Okay. All right. So one integral that occurs over and over again is this guy, secant cubed x dx. Now I'm going to do it in a second, but I said if one of them is odd, like if the secant is odd and the tan is even, even on this one, what you would have to do is write it as secant squared x minus 1 secant x. And what you see is you have to integrate secant cubed minus secant. And these things keep building on each other. I guess Greg Newsom got caught red-handed and no mask. Okay. So with this one, what we actually have to do is haul out integration by parts. Okay. So we'll use parts on this. U will be secant x and dv be the easy derivative guy. So now du is secant x tan x, and v will just be tan x. So our integral is going to be uv, whoops, minus the integral of b du. Okay, now notice that that is that thing upstairs. I mean, up above that I had already pointed out. So this is going to lead to secant x times tan x minus the integral of secant cubed x minus secant x. Okay, and so that is the integral of secant cubed x. So if you bust the two apart, minus the integral of secant cubed x, and then plus the integral of secant x dx. And now we move this guy over here and we integrate this guy as we did above. So two integrals of secant cubed x dx is equal to secant x times tan x plus the natural log of secant x plus tan x. And if you're one of these people that does lots and lots of homework problems, you'll see as the semester goes on, this integral just keeps showing up because of certain formulas that we use to find arc length and so on and so forth. 1/2 secant x times tan x plus 1/2 the natural log secant x, or if you want, you can put the whole thing over 2. Okay.
Why did that become an absolute value, Professor?
Because of what happened way up here when I integrated it. This is equal to the natural log of the absolute value of u. That's the antiderivative. You just need to know that from last semester. Like I was telling my guys last semester, this semester is just kind of a continuation. It's better when we do it in the spring and 180 in the spring and then 185 in the summer, because you know you get a maximum of maybe 4 weeks off, but more like 2 weeks, you know, or something like that. But you know, it'd take almost 7 weeks, or 7 weeks, almost 8 weeks off. Anyway, so now if there are bounds in any of these things, you just treat them accordingly. So like, for example, if we go back to integration by parts, since we just did an integration by parts problem right here, if we are going to integrate the natural log of x dx from the values from 1 to 2, well, remember, when we did the parts, we did u equal log x, du equal dx, db equals dx. Du is 1 over x dx. B is just x. So it's uv, x log x. But you need to evaluate them at those things. And then you integrate that guy. Or if you like, you could have just remembered the answer, x ln x minus x, and plugged in the bounds. Could also have done that. All right, so this is going to be equal to 2 natural log of 2 minus 2 minus log of 1 is 0 minus 1. So it looks like that's the natural log of 4 minus 1. This is one of the few times where I would put the -1 over there. Okay, so you just deal with bounds accordingly, you know. Okay, now there are a handful of these exercises where he's got stuff like this. The integral of the sine of 2x times the cosine of 3x or something like that. Okay, and in the book on page 484, if you have the Stewart book that I'm looking at, but it's always right before the exercises in 7.2. Just find that page, whatever book, Stewart book you're using. And he's got all these ridiculous trig identities that he's expecting that all of us are going to remember, which, let's face it, we're not. Okay. So what you do here is you just kind of use trig identities. Like, I know that the sine of 2x is 2 sine x, cosine x. I could write the cosine of 3x. And this is what I'm talking about, guys. Figure it out on your own. You're not going to remember everything. None of you, when you get to UC Irvine, tell you what, I'm going to Ralph's today. One of my old students, works at Ralph's. He's graduating. He's graduating from UC Irvine, I think, next fall. And he's a Newport Harbor kid. Anyways, he took my 180, 185, and 285 class. And if I go see him today, I go, hey, Cam, you remember the identity for the sine of A times the cosine of B from page 484 in the Stewart calculus book? He's majoring in mechanical engineering and doing quite well. He's going to look at me and go, fuck no. Okay. So you just have to figure these things out on your own. The identity here is cosine of x cosine of 2x minus the sine of x times the sine of 2x. And then we take the cosine of 2x and we write it as cosine squared x minus sine squared x. And then this one, we put the 2. Okay. So our integral ends up being, there's a 2 sine x cosine x times the quantity cosine cubed x minus cosine x sine squared x minus 2 sine squared x cosine x. And these look like they can be combined, right? So I'm going to get a 2 outside here, and then sine x cosine cubed x minus 3 sine squared x. Okay, now as gnarly as this goes, at least everything's of the same argument. So this is the kind of stuff that we have fun with. Oh shit, I'm late. I gotta get my daughter. Okay, I'll get over to the door. All right, so next week will be our last week of doing this stuff live online, even though I'm going to keep trying to do it live online. All right. So before I hang up here, let me check the chat real quick. Then I got to get the hell out.
Professor.
Yeah.
I remember in the first class you were saying something about running Zoom from the classroom. Does that mean like on a non-test day we could just stay at home and watch your lecture from?
That's what I'm planning on, but like I was telling you guys, the administration doesn't want us doing that. But
Yeah, because my brother's high school did that for a while and it actually worked really good.
I'm going to do it until they tell me not to. All right, guys. So in 7.2, just do as many of those integrals as you can. If you get stuck, just email me, tell me, take a picture of it, send it to my Muir, and I will get back to you. Okay?
Yeah, Professor, I have a question.
Okay.
Is there any way we can review the stuff you just said in the lecture from a past class that you had recorded in other semesters?
There's the first summer of the lockdown, there's an entire, every single lecture from 185 was recorded by Brian Wagner. You just got to search it on YouTube. search my name and then
OCC,
math.
OCC Math 185 summer class, right?
Yeah, Brian put them all up there and didn't delete them all. All right, guys, I gotta get out of here.
Thank you.
Talk to you guys later.